Welcome to this explainer. I am absolutely pumped to guide you through today's topic because honestly, we are looking at something that represents a massive leap forward in artificial intelligence. We're talking about the evolution of AI teamwork. Now, think about how much AI has advanced recently. It's mind-blowing, right? But also think about how rigid it can sometimes be when things don't exactly go according to plan. Well, today we're unpacking a fascinating framework that completely changes the game. So let's kick things off with a pretty crucial question. What actually happens when powerful multi-agent AI systems hit a wall? You see, right now, we have these brilliant AI agents working together in teams to solve incredibly complex tasks. But their communication structures, who talks to whom and in what order, are almost always fixed right from the start. So what happens when that fixed structure fails right in the very middle of a task? Well, they get stuck. The whole workflow just literally grinds to a halt. To understand how we fix this, here is our roadmap for this explainer. First, 1. The AI teamwork problem. 2. Meet self-evolving MANTA. 3. How MANTA adapts instantly. 4. Smashing AI performance benchmarks. 5. Why this framework matters. And finally, 6. Sorting out the MANTAs. Okay, starting right off with section 1, the AI teamwork problem. The exact bottleneck we are facing today is static AI topologies. These are highly rigid, pre-optimized structures. Basically, when AI agents rely on a pre-planned strategy and that strategy encounters an unexpected hurdle during inference, the whole system just breaks down. They simply cannot adapt. Contrast that with MANTA. MANTA brings real-time, self-evolving adaptation to the table. It acts as a true evolutionary leap, allowing the AI to literally reorganize its own communication network on the fly to overcome whatever hurdle is in its way. Which brings us nicely to section 2. Meet self-evolving MANTA. Let's break down exactly what we're talking about here so we don't get lost in all the technical jargon. MANTA stands for Multi-Agent Network Topology Adaptation. In simple terms, it's a framework that enables AI agents to self-evolve their communication structures while they are actively solving tasks. Instead of human developers having to jump in and rewrite the rules when the AI gets stuck, MANTA allows the agents to figure out a better way to talk to each other entirely by themselves in real time. And look, it's absolutely crucial to understand that MANTA is not just another flashy new AI model. No, it's a completely new framework for how existing agents collaborate. It completely moves us beyond those static or offline optimized topologies by introducing real-time structural updates. That is the core innovation here. It means problem-solving efficiency goes completely through the roof because the team structure itself becomes part of the solution. Let's look under the hood in section 3, how MANTA adapts instantly. Think of MANTA kind of like a genius sports manager watching a game from the sidelines. It operates in this really elegant 3-step cycle. Step 1 is initialization. The manager starts the game with a task condition topology based on past experience. Basically, they pick their very best starting lineup. Step 2 is monitoring. The framework actively tracks collaboration traces during deployment. So the manager watches the game to see if the strategy is actually working out on the field. Then step 3 is adaptation, applying bounded updates when the current organization just isn't cutting it. If the team is losing, the manager doesn't just sit there crossing their fingers. They actively change the formation mid-game to outsmart the opponent. So what exact plays can this AI manager call during those bounded updates? Well, MANTA can trigger agent role reassignment. It can instantly add or remove communication links between specific agents. It can entirely change the execution order of tasks. Actually, it goes even further. It can adjust which agents can see what information and even modify the validation pathways to ensure the work is being double-checked properly. It dynamically rewires the entire workflow to keep things moving without a hitch. Let's talk about the hard proof in section 4. Smashing AI performance benchmarks. The developers put MANTA through some incredibly rigorous testing across 5 highly diverse domains. We're talking information seeking, tool use, planning, workflow execution, and mathematical reasoning. They didn't just test this thing on one easy metric. They literally threw the kitchen sink at it. And while it excelled across the board, its absolute best performance was found on a really complex planning benchmark called PlanCraft. Now, the absolute strongest baseline, the best-in-class static multi-agent systems out there right now, scored a very respectable 68.2 average. But MANTA, it soared right past that to an impressive average score of 74.0. That clear dominance, right there, is the power of dynamic, real-time adaptation in action. To put a really fine point on it, Manta achieved a 5.8 percentage point jump over its strongest competitors. And in the world of highly advanced AI benchmarks, a nearly 6-point leap isn't just some minor incremental iteration, it's a massive structural breakthrough. So what's the big picture? That brings us to Section 5, why this framework matters. This framework matters for 3 absolutely critical reasons. First up, scalability. Because Manta can manage its own structure, you can trust it with massively complex, multi-step workflows without having to sit there and micromanage the agents. Second, flexibility. Look, the real world is messy, right? Manta adapts to unexpected challenges during inference, meaning while it's actually out there doing the job. So it doesn't just crash the moment it sees something new. And third, efficiency. It actively reduces those annoying communication bottlenecks, meaning your tasks get done faster and ultimately cheaper. Let's ground this abstract framework in some highly tangible, real-world applications for a second. If you're in research, imagine AI-driven research assistants that completely reorganize themselves based on the new data they uncover. In management, you could deploy autonomous workflow managers that restructure entire corporate data pipelines on the fly. In security, imagine multi-agent cybersecurity defense systems that literally change their defensive formation the exact moment a hacker tries a new tactic. And for broader tasks, it enables large-scale planning and reasoning that our current static AI simply cannot handle today. These self-managing AI teams are going to absolutely thrive in these arenas. Finally, a quick point of clarification. In Section 6, sorting out the mantas. Just a quick public service announcement here, because as of July 2026, there are actually 3 distinct frameworks floating around the AI space with the name Manta. The one we've just spent our time exploring is Manta Multi-Agent, which is entirely focused on real-time network topology adaptation. But just be aware, there is also a Manta Multimodal out there, which focuses on aligning visual and auditory inputs into a unified text base. And there's a Manta Evaluation Framework, which tests large language model alignment under adversarial conversational pressure. So when you hear the industry buzzing about this game-changing, self-evolving collaboration, just remember it's the multi-agent network topology adaptation we are celebrating today. And that brings us to the end of our explainer. I want to leave you chewing on this highly provocative final question. If AI can now intelligently restructure its own workflows in real time to overcome failure, what human bottlenecks is it going to replace next? We are truly entering an era where the AI doesn't just do the grunt work, it actively manages the team doing the work. Thank you so much for joining me to explore the Manta framework. Keep questioning, keep learning, and I'll catch you in the next explainer.